All right. Hi, guys. So today we're going to be talking about the predator-prey relationships lab. So let's read through the introduction together. Okay. So in natural communities, all populations are interdependent. Predator populations and prey populations rely on each other. Changes in predator population can severely affect the population of their main prey animal and vice versa. A research team studied the interaction between two wild populations, gray wolves and white-tailed deer, over a period of 12 years. The wolves are natural predators of the herbivorous deer, and you will see other populations help keep each other within the carrying capacity of their habitat. Okay, so these are some words that we've been defining in class. All right, so you're going to use your notes to help you answer the analysis questions later on. So today we're going to be creating a double line graph. Okay, we're going to use the information from the data table, which we'll look at in a second. You're going to be sure that you label both axes. Okay, you're going to make appropriate scales. You're going to use the key provided, and you're going to make sure that you plot all data points and give your graph a title. Okay, so let's look at the data table and the graph together. Okay, so here you have your data table. All right, you're going to, again, make a double line graph. So you need to know which one's your X, which one's your Y. You need to then create appropriate axes. Okay, so you're going to label your axes, and then you're going to create your numbers for your axes. Okay, little hint, right? We're going to find the lowest number, the highest number, and we're going to see how we can get evenly spaced up to that highest number. Okay, you don't have to start at 0, and if you're going to skip spaces, make sure that they're even. Okay, make sure you give your graph a title. Remember the effect of the independent variable on the dependent variable. And then you have to use your little key in the corner. Okay, so if you look carefully, the deer has a triangle shape around the point, and the wolves have a circular shape around the point. Okay, if you have any questions, all right, feel free to ask. All right, lastly, once you create your graph, you should have 2 line graphs, and you should analyze the patterns. Okay, you're then going to answer some analysis questions. Okay, so the questions are as follows. 1, you're going to look at, of the 2 population studies, which is consistently larger, okay, and you're going to explain why. 2, you're going to describe what happens to the wolf population as the deer population increases, so you're just looking at the trends of the graph. Okay, 3, you're going to describe what happens to the deer population as the wolf population increases. 4, what do you think would happen to the population of gray wolves if the population of deer increased to over 100 individuals? And explain. Okay, 5, what do you think would happen to the wolf population if a drought, so that's a period with no rain, killed off most of the plant life in the area? Okay, and then you're going to explain why. 6, what might happen to the local plant life if the wolf population dropped down to only 6 or 7 individuals, and why? And then 7, how does the predictable shift in population size help to maintain a dynamic equilibrium in an ecosystem? So remember, dynamic equilibrium, right? That means stable ecosystem. Okay, so we're going to go through those questions again. All right, we will go through those answers when we all finish. All right, if you have any questions, please ask. And make sure that for each question we're explaining and using our scientific vocabulary from our notes. All right, have fun.